Welcome. We're so glad you can make it tonight. Thank you so much for coming. We're excited to share the Watershed Sampling Day data with you and to be able to have this time together. This is something that has been a long time in the making. Us here at the Collaboratory are very excited to be able to get it out with our partners at the Conservation District, as well as, some students that have been helping us along the way. So thank you so much for coming. We'll go ahead and get started. So first things first, we'll introduce ourselves. My name is Megan Guy. I use she, her pronouns. I'm the outreach coordinator for the Pittsburgh Water Collaboratory. We're a group here at the University of Pittsburgh that hopes to bridge the gap between academic research and community need. So super glad to be here tonight, and I'll let the other folks introduce themselves.
Hi, I'm Amy Miller. I'm the Watershed Program Manager for the Allegheny County Conservation District. Through our Watershed program, we do a lot of watershed planning work, outreach and education and restoration projects. So happy to be working with PIC Water Collaboratory and the good work that students have done.
Hi, everyone. I'm Gabby Zucolato. I'm a PhD student at University of Pittsburgh. I'm going into my second year of my PhD program. My research focuses a lot on water quality in the Ohio River Basin, specifically using remote sensing, and I'm also on the leadership team for the Pittsburgh Water Collaboratory.
And I'm Robert Murphy. I'm an undergrad going into my senior year at Pitt, and I was brought on as a summer intern to help with this project and help with other projects related to water quality in the Ohio River Basin.
Awesome. So welcome. And thank you all so much for participating in this day. A lovely flashback to May 6th and the glorious day that it was. I think it was one of the first beautiful spring days that there was no rain, there wasn't a cloud in the sky, and some of these pictures are from you all, and are a testament to what a beautiful day it was and some of the streams that we have within the area. So wherever you went through the day, we appreciate you. This wouldn't have been possible without your help and support. This is something that is really important for us to have more data on what the tributaries are feeding into the main stem rivers. So without you, this couldn't have been possible. And just a testament to some of the beautiful areas as well in the area that I learned about through this process. I hope that you were able to enjoy them just as much while you were doing this project as well. So there will be more pictures, but for the meantime, we'll get started into why this is important, and then we'll dig into some results. So thanks for being here.
Okay. So just to give a little bit of background and motivation, if you attended our webinar that we had before the sampling event, some of this will probably be repeat, but this sampling event has been sort of a few years in the making, and an event that really grew out of this idea that we don't have a lot of data that's collected in some of these tributaries that feed into the main stem rivers around Allegheny County. So if we look at our historical water quality data, we see that most of our data is centered in these larger sections of rivers, and you can see that in the map that's on the right. So this is an example of some of our phosphorus data collection that we have. So the larger the red bubble, that means the more number of samples or number of observations we have of phosphate data at that point. What you see is those larger bubbles are really centered on some of the main stems of the rivers, and we have either fewer bubbles or smaller bubbles really centered around the tributary areas. So we really wanted to put together this event in order to try to even that out a little bit and get some better understanding of what's happening in some of those tributaries. So just an overview of the sampling day. We ended up with 30 wonderful volunteers. Between those 30 volunteers, we were able to sample 44 sites on 40 different streams. It's important to note as we go through the results that there's no sort of time scale to this. All these samples were taken on the same day. within about a 2 to 3 hour period of each other. So although we don't have a time series to look at, it is interesting that we have sort of this snapshot of what water quality looked like in these 40 different streams all within the same morning, which is really unique. So what all did we end up testing for? This is a shortened list. All of our parameters sort of fall into 2 categories. So we ended up doing some nutrient sampling and also some metal sampling. The nutrients that we looked at were nitrate, nitrite, total nitrogen, and total phosphorus. Rob will talk a little bit later about why we decided to look at some of those parameters specifically. Then as for metals, again, this is a very condensed list. We ended up measuring above 20 different types of metals. But just a brief list: aluminum, iron, lead, arsenic, zinc, copper, and many more that you'll be able to see later. And then just a little bit more sort of behind the scenes insight on what the sampling day looked like after all of our volunteers went home. So the last thing our volunteers did was drop off their sample bottles at one of the locations that we had set up. Then our pit people that were at those locations transferred those bottles down to the campus and into some of our water quality labs. And that's where these pictures are coming from. So all of our samples, because we were looking primarily at dissolved constituents or dissolved water quality parameters, the first thing that they have to go through is filtering, which Rob was a massive help with. So you can see the filters that we used up in the right-hand corner, and then our parasaltic pump systems in the lower right corner that then the samples get filtered through in order to remove some of the larger pieces or the particulates. Then once the samples were filtered, they got divvied out and smaller subsamples were taken to different equipment, spectrometers and things like that, depending on the water quality parameters that we were trying to measure. So that's the general process. So I'm going to pass it over to Rob now. Like Rob mentioned when he introduced himself, he's been an intern on this project, and he's been primarily working with me and Megan, taking some of the data that came from this analysis and putting it into a really awesome, user-friendly geospatial tool for people to be able to use. And he's going to talk about that now.
Thank you, Gabby. As she mentioned, I've been working on making an interactive website that many of you have received the link for to display this data and to hopefully expand the audience from which this would reach. In case you were interested in exactly how this came to be, more background information that you might remember from the original webinar is available here. The Water Collaboratory, in collaboration with the Allegheny County Conservation District, held the sampling event to educate those interested about the quality of Allegheny County's local waterways. This was, as Megan mentioned, a long process, originally dating back to 2018 and 19, but then a little thing called COVID-19 certainly derailed this plan that was originally scheduled to take place in 2020, and instead happened several years later, as in 2023, until May 6th. Everybody got out there and we were able to sample all the sites Gabby mentioned, 44 sites across 40 streams. Of those samples, the parameters measured over 30 parameters. These were ones that we found to be of particular interest. Nitrate, nitrite, phosphorus, all these are the nutrients. Nutrients, of course, leads to rapid growth of plants, as we can see in the Ohio River Basin with the large-scale algal blooms in 2015 and 2019. But of course, if these are drinking, these can cause harms to human bodies. Common sources are areas such as sewage, fertilizers, runoff. Anything you could think of that would help plant grow would typically be associated with these parameters. And then, of course, when you're talking about Pittsburgh, you have to talk about the steel industry and any legacy pollution that might remain. Iron and manganese were shown to be rather telling in terms of what the water quality looks like in terms of metal pollution. While these certainly can be from underlying lithology, something just maybe iron-rich rocks underneath the waterways, but when you're coming to Pittsburgh, you almost certainly have to consider the steel production and mining operations that have occurred for decades here. And while there's no immediate health effects associated typically, the discoloration of water, most famously in places such as Flint with orange water, certainly can have an impact on the local waterways. This first map here, as you'll see with all these maps, is fully interactive. If you want to click on any of these points, you'll be able to see basic information. What sample number we labeled this as, that was the big bottles you received on the day of the sampling. Name of the stream, location description, and any notes that were left by any of the people that were taking samples that day. All of that's available here for any of these points. If you just click on any one of these, it will tell you everything you want to know about that specific area. Here, as Megan mentioned about many more pictures, well, here they are. Any pictures that were taken that day of a specific site you can find here. If you just click on any of these pictures, it'll zoom to, and you can see where on the map this particular site was. If you keep scrolling through here, it'll go through the entire slideshow, but if you're only interested in specific slides, just in this little white X, you can back out, continue scrolling, and then click on whatever site you might be interested in to look at further. And then here's the real gravy of it all. The data visualization. What did all of these parameters turn back? What exactly did we find in these areas? Something to note, very important here, is that my analysis going forward, I used EPA drinking water standards as the primary measurement through which to base our parameters off of. Of course, drinking water is not surface water, which we measured. So something to keep in mind there is that before entering drinking water supplies, these are typically treated thoroughly before anybody has a chance to actually consume any of the water. So just something to keep in mind as we go further on, because in particular, this map here, I colored this based off of green, yellow, and reds. Green significantly below the EPA MCL levels. Yellow is still below, but within 10% and exceeding that. And red does exceed those EPA MCL levels. And in case you want a full screen view of any of these applications, this little button in the top right here, you just click on there, it'll open up in a brand new tab. Repeat the same directions in case you need a refresher. And then from there, you're free to view any of these 4 parameters that we color coded. As you can see with phosphorus, total phosphorus in the area in terms of compared to the EPA MCL levels was relatively well. Of course, the one site down here was exceeding it. The level is just 1 part per million total phosphorus exceeds the EPA MCL, and this one is 1.18. Similarly, nitrate, another nutrient that tends to be highly correlated with phosphate, is shown very similar. So these are 2 separate parameters by which nutrients were incredibly high in this area and relatively low in other areas. Nitrite too was incredibly high. It was very high in this one site too. This is the Coal Valley Road, a stream running right by there. While nitrite was very high, it didn't exceed the EPA MCL, so it's not included here, but this relative area was still high compared to the others. And then iron is the complete opposite of this, where we see many green sites with only the one red sticking out. Iron, which we used to look at legacy pollution, was shown to be incredibly high in the vast majority of the waterways, with even yellow speckled throughout. Manganese, similarly, highly exceed, at least relative to phosphorus. These iron and manganese are, of course, typically seen in areas with mining, steel production, legacy pollution. So it would make sense to see these kinds of measurements in the Pittsburgh area. If you want a more numerical approach, then this is the application you're looking for. Once again, I'm just going to hit this button top right to open up full screen. With the same parameters that were below or above, apologies, you can view the exact numbers that of all these sites. If you hover over any of these bars, it'll show you the site. The x-axis is the site numbers, and the y is the concentration. Little line you see stroking through of these first four is the EPA MCL level. Hovering over these bars will highlight it on the map. Something to note is that even if you see it highlighted in the bottom left where you see the bar, you have to be on the blue bar itself. You can't be in the little highlighted area, otherwise it will not appear on the large map. So if you go through, you can see exactly where these areas exceeded these EPA levels or were just relatively high compared to other sites. Sodium here, I will talk about a little later, but as you can see, there are two areas that were greatly have much higher concentrations of sodium relative to other areas. If you want to just specifically look at certain site numbers, you can manipulate this bar as you see fit to zoom in on one particular area, but this can provide a well-encompassed view of the areas if you're more interested in the numbers. But what does this all mean? Why, where is this coming from? What could this possibly actually mean? As I mentioned before, nutrients are typically associated with things such as farming, sewage, anything that you can think of that might make a plant grow is typically associated with the nutrient parameters that we measured. This area here, this is a map of the phosphorus points and the little stars here denote municipal waste facilities in the area. I chose to zoom in on this little red point because this was the only one that exceeded we saw the highest phosphorus, nitrate, nitrite levels. If you click on any of these stars, you'll be able to see exactly what these sites are. For instance, this is an abandoned landfill, but if you click on any of these, they could be anything from a landfill to wastewater transfer facilities. This, of course, is not indicative of this dump 100% causing this spike in nutrients. As Gabby mentioned, this is just a snapshot. This is a one-off. It's hard to draw conclusive results from one-off snapshots. You need a more long-term time series to make anything meaningful from that. As I mentioned before, when showing the charts, sodium was an incredibly interesting parameter to look at. Here, I abandoned the red, yellow, green, and instead chose a simple gradient as the best way to show this. The more lighter colors is low, and the redder, darker colors is high concentrations. So as you can see, these two sites stick out like a sore thumb. These two sites are Plum Creek and Upper Plum Creek, which are samples W25 and W30 respectively. As you can see, they over 600 parts per million of sodium. This is over 6 times the average of the sites, which was only around 105. So sodium, typically you would associate road salt. That's the first thing that'll come to mind, considering the immense amount of snow Pittsburgh might see and the ice risk. Road salt is, of course, applied very heavily. But something to note, these were taken in May, and these 2 points are so much higher than every other area. So pinning this down solely to rolled salt might not be the greatest. It's likely that something else is occurring here. But once again, this is just a snapshot, so it's hard to draw any conclusive results from just this one-off sampling day. And then if you want to see all these parameters for yourself, exactly what we measured, exactly what the number is, this is the app you're looking for. This is how you can access the CSV. The first thing you want to do is open this up in a new tab. If you try to follow these steps I'll show you while still in the StoryMap itself, you will not be prompted to save it. So you need to open this up in a new tab. But once you have it open, the thing you're looking for is this little tongue down here. You just open this up. This will show you the complete attribute table for all the sites mentioned. Simply going options and then export all to CSV. You'll be prompted what you want to name the CSV file, and you can select where you want to download it. Something important to note is this filter by map extent. If you want all the points, you should see 44 features down here. If for whatever reason you see less than this, you likely have filter by map extent turned on and you're zoomed into several points. Whatever you're zoomed into, that will be what's converted if you have this little white box around filter by map extent. For instance, here I have 5 features selected. So this would be, these 5 points would be what I would download. But if I deselect this box, this number jumps back to 44. And once again, I'll have access to all of the data. The data included here is everything from the stream names, descriptions, anything you saw in any of the pop-ups before this is included on here. And all of the parameters measured too, including those that I have not shown off. Everything from lithium to uranium, chromium, anything metal-wise available is included here. Including things such as total nitrogen and total phosphorus, all of that's included on here. And going forward, we hope that this campaign encourage future community engagement activities, be that public engagement or just becoming more knowledgeable of the waterways. And we would like to thank everybody from the Hillman Foundation, the Allegheny County Conservation District, Pittsburgh Water Laboratories, and of course, a thank you to all the volunteers here that made this event possible. This was a great event, and I hope that everybody can take some pride knowing that they're helping keep the county safe and clean. And I think now we will open it up to a larger discussion as I'll toss this off to Megan.
Thank you, Rob. And kudos to Rob. He has been working on this all summer. So he's come up with a great webpage, and I hope that you all can take the time to explore and learn not only about your site, but about all the other sites across the county as well.